We have already discussed that this has three main categories. What are floating point numbers? Anyone? Prerna? Prerna? You're already on unmute. Please speak up. What are the what are floating point numbers? Prerna, I'll remove you from my class. You have to speak up once asked for it. Okay?
No, ma'am, I don't know.
You don't know. Archita, what are floating point numbers?
Decimal numbers.
Uh, yes, you can say decimal point values. So we have for these decimal point values in the DLX architecture, we have a separate set of hardware and accordingly a separate set of instructions for operating on the data which is in floating point. So basically now when we started discussing these instructions, they had three main categories. Yes. So we had the arithmetic, we had the conversion, and we had the set on comparison. I think we have discussed most of these. The one more thing that we have with floating point arithmetic is that all the operations are done in a register addressing mode, and encoding is also in an R-type mode, right? So all are R-type instructions, and they operate upon values stored in floating point registers or pairs. Why pairs? Aryan, why pairs?
Yes, ma'am. Because मतलब कि पॉइंट के आगे वाला पार्ट एक रजिस्टर में जाता है और पॉइंट के बाद वाला पार्ट दूसरे रजिस्टर में.
जरूरत तो नहीं है. प्रत्युष आनंद, why did I say register pairs? फिर तो बच्चे मैं आती हूँ, बोलती हूँ और चली जाती हूँ, इसका मतलब आप लोग सुनते ही नहीं हो. Saksham, why did I say floating point register pairs? There's a chat message. I don't know. Okay. Saksham, will you speak up?
Yes, ma'am.
Why did I say register pairs? Floating point register pairs.
Because, ma'am, a floating point register needs to store more integers. It has to store number before decimal point and after.
So if I have a 32-bit value, I have one floating point register. This means I do not have a provision of storing the decimal point value. But we have a provision with RISC-based machines. Specifically, if we talk about the DLX processor, we have a provision of operating upon 32-bit data as well as 64-bit data. And this 64-bit operation is possible only with floating point numbers, not with integers. So with floating point numbers, if I am operating upon 64-bit of data in one go, this means I need a register pair to do it. I cannot store 64-bit value in a 32-bit location, which is just one register. Right? ये याद रखना है सबने, मैं बड़ी बारी बता बैठी हूँ पहले भी. So we always here have, and I am just writing this for you all. So we have floating point operations. These are possible on 32-bit values as well as 64-bit values also. अब जब 64-bit वैल्यू पे किसी प्रोसेसर को ऑपरेट करना है तो डेस्टिनेशन और सोर्स भी तो अकॉर्डिंगली लेनी है ना. नाउ वन फ्लोटिंग पॉइंट रजिस्टर is 32-bit. This means I have to take a floating point register pair. All right, and we can have even parity, or I should say even pairing, and we can have odd pairing. Riya will tell me if I have even pairs, from where will my counting of the register pairs start?
Ma'am, F0, F2, F4, and so on.
Very good. And if I just write a double, so this is what I was explaining last time. I'll just stop this now. So this is what I was explaining last time, that if we have these operations, we have the add, subtract, multiply and divide, these operations are possible on 32-bit values. But if I have to operate upon 64-bit double precision numbers, for that a suffix d, see d says double, right? So a d suffix is used with the respective opcode. Add double, subtract double, multiply double, divide double. अब अगर इसमें मैं ये वाली इंस्ट्रक्शन लिखती हूँ, add double f0, f2, f4, this will by default consider f0, f1 as the destination register pair, f2, f3 as the first source register pair, f4, f5 as the next source register pair. तो ये बाय डिफॉल्ट क्या करेगा, आपके f2 f3 की वैल्यू को contents of f2 f3 will be added with contents of f4 f5 and the result will be stored where?
f0 and f.
Very good. So it will be stored in your f0 and f1. Your exams are approaching and I have to just finalize the date of your first quiz with Sanda sir. Please पढ़िए, ये सब्जेक्ट ऐसा नहीं है कि आप एक रात पहले पढ़ेंगे तो आपको आ जाएगा. Secondly, आप वर्चुअल मोड में पढ़ रहे हैं. It is not, everything is not face to face also. So self study is very important. See, you're paying so much, all of you. You must bag a good placement by the end of your degree here. And for that, they ask you all these core courses only, what you have studied in your previous years. So if you're preparing for, any embedded systems company, they will ask you digital electronics, and they will ask you ARM processor, they will ask you computer architecture, they will ask you about DSP processors. Accordingly, prepare karna shuru kariye. This is high time. If you're not serious about your career, even studying in Thapar will not fetch you a job. Let me tell you very clearly. So you have to be serious about your studies. पढ़ते हैं, कुछ बच्चे पढ़ते हैं, जो नहीं पढ़ रहे हैं उनके लिए बच्चे, जो क्लास में कराया है उसको ध्यान से सुनो, सिर्फ एक रीडिंग की जरूरत पड़ती है उसके बाद. ठीक है? Okay, let's come to the studies now. So the next instruction that we were discussing last time was convert floating to double and convert floating to integer. So as the name says, this instruction is going to convert, I'll just take the example. Yes. If I take the first one, right, this is convert floating to double from, say, okay. So suppose the instruction is given as convert floating to double f0 to f2 f3. This means a 32-bit value available as a single precision number has to be converted to a double precision number in f2 and f3. By default, the data remains the same. The unused spaces will be occupied with all zeros. I hope it's clear to everyone. ये last time मैं करवा रही थी. There is a chat message. Just a minute. Ma'am, last time you were explaining convert f to d, f0, f1. Okay, I'll take the same example, f0, f1. So this is convert f to d, f0, f1. Right? Let's take the same example as we were doing last time. Now see the instruction when it is fetched and decoded. The decode unit just seeing the opcode, which is, there is one more chat message. Ma'am, the double multiply operator is mult d or muld. It is mult d, bache, but in some literature, see actually these risk-based machines which have been introduced by Hennessy and Patterson, they have undergone a lot of transitions in just a span of 2-3 years. So maybe in some literature you will find mult, in some you will find muld. But the point is, whatever processor's instruction set is defined, we have to use the same. ठीक है? तो अगर हमारे को DLX दिया है और उसमें mult D लिखा है तो हम वही यूज करेंगे. हो सकता है MIPS 32 में MULD यूज होता होगा. जैसे मैं आपको एक एग्जांपल देती हूँ. If I talk about add double, for DLX we write ADD suffix D, while if I talk about the MIPS 32, they write DAAD. So they add a prefix, right? So it depends from processor to processor. Well, the meaning remains the same. Clear hai? Yes, Kiran, is it clear? You can speak.
Yes, ma'am.
All right. So actually, this is processor specific. Just that the opcodes, one or two alphabets might vary, but the meaning remains the same. If I talk specifically about DLX processor, we write suffix double. While if you talk about MIPS 32, they use prefix. You can check this in the 5th edition, I guess. It is available in the 5th edition of Hennessy and Patterson. So actually, the point is that whatever processor we are currently talking about, we have to consider what is mentioned for the same, right? Now, let me take this example, what I was explaining in the last class. This says convert floating to double F0, F1, right? So floating is actually my single precision floating point register F1, and my F to D. D means it has to be converted to a register pair, which is right now F0, F1. ये दो registers का pair उठाएगा by default. ठीक है? अब जो भी F1 की value है वो copy हो जाएगी वापस F1 में, और F0 में सब zeros आ जाएंगे. क्यों? Oh, sorry, I said ulta. F1 will be copied in F0 and F1 will have all zeros now. Not to confuse you anymore, I'll just take one more example and this becomes more clear then. Convert F to D. Say I am taking F4, F2. ठीक है? अब ये थोड़ा अच्छे से clear हो जाएगा. Then we can take the reference of the above instruction in the lower one. Now see, if I give the same instruction with different registers, say I have to copy the contents of F2 register into the register pair F4 and F5. Now I have a single precision number converted to a double precision number. Anyone who will tell me where will F2 go? The lower order bits or the higher order bits?
F4.
Yes, it has to go to F4, to the lower order register, right? And the higher order register will be all filled with zeros by default. And when next operation, suppose is add double, it will by default add bit by bit the lower order registers with lower order registers data and higher order registers with higher order registers data. I hope that's clear to everyone.
Excuse me, ma'am.
हाँ जी.
मैम अगर वो रजिस्टर पेयर ले रहा है तो F2 और F3 नहीं होगा?
नहीं. The instruction is some. See, you have to read what the instruction is saying. The instruction says convert floating to double. This is a convert operation that converts a single floating point number to a double floating point number. This means a 32-bit value to a 64-bit value.
Okay, got it.
So the source will be one register and destination will be two registers. And when it is copying the data, it has to make sure that it does not lose its actual sense. अगर आप 32 को 64 बिट में कन्वर्ट कर रहे हैं तो हायर ऑर्डर बिट्स में तो सब जीरो ही जाना चाहिए, नहीं तो डेटा की सेंस चेंज हो जाएगी. यू गेटिंग माय पॉइंट?
Yes, ma'am.
If I have to write 10 in 4 digits, I will write 0010 rather than writing 1000. I hope you're getting my point now. All right. So accordingly, the single precision number in a single floating point register gets converted to a double precision number in a register pair. The opcode itself identifies, what has to be done. Let me just see, there is a chat message. मैम F5 में साइन बिट नहीं आएगी, डन इन नहीं आएगी बच्चे, नहीं आएगी कीर्ति, नहीं आएगी. वो इंस्ट्रक्शन बताती है कि उसमें आना है कि नहीं आना है. सो राइट नाउ साइन बिट नहीं कॉपी होगी. ये सिर्फ आपका सिंगल प्रिसिशन को डबल प्रिसिशन में कन्वर्ट कर दिया. You know, maybe I have a 64-bit data which has to be added to a 32-bit data. There is no direct instruction for adding two numbers which are on a different scale. So for that, I need to first of all, convert my single precision data to a double precision and then give a add double operation. Are you all getting?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay, good. So I'll just move on. Yes, the next operation is convert floating to integer. So I'll just try. अच्छा, अब इसका example अब एक बारी मुझे बता दो before moving on to the next one. Now this example which I was taking in my last class, this says convert floating to double from F1 to F0 and F1. Now what should happen? This will not give you a syntax error. Somebody had a doubt, ma'am. Will this give a syntax error? No. This will not give you a syntax error. The syntax is perfectly...
It will override, ma'am.
Yes, this will override. Very good. And fill the higher order register with all zeros. So just that your number has got converted from a 32-bit value to a 64-bit value in F0 and F1. That's it. All right. Okay, I'll move on now. The next operation is convert floating to integer. Convert floating to integer. बताइए सोर्स में क्या आना चाहिए और डेस्टिनेशन में क्या आना चाहिए?
मैम सोर्स में फ्लोट वैल्यू आनी चाहिए.
वेरी गुड. और डेस्टिनेशन में
इंटीजर
register.
नॉर्मल रजिस्टर.
Very good. So accordingly, the opcode says convert floating to integer. This will convert the 32-bit value available in any floating point register to a 32-bit value in a general purpose register. Now see, how did we store floating point numbers? It was an integer multiplied by 10 raised to the power something, right? So this will already have some integer value. The decimal point is neglected and directly the integer gets stored into the general purpose register R1. I hope it's clear. Sayam?
Yes.
Okay, Sayam will speak up. If I now give an instruction of convert floating to integer from F5 to say R4, what will this instruction do? Sayam, unmute yourself and speak up. Sayam Mittal. No.
Yes, ma'am.
What will this instruction do?
Ma'am, it will convert the floating point to an integer one.
Very good.
We have floating in F5 and it will return an integer to R4.
Very good. Moving on. I'll not spend more time on this. All right. So the next operation that we have is convert double to floating and then double to integer. Now, we did conversion from a single precision number to a double precision number. We do have options for converting from double to single precision as well and from double to integer as well. ठीक है, इसमें आपका round off होके automatically convert हो जाता है. So I'll just take one example here. I should have one. Yeah. All right. So just mute yourselves, everyone. Yes. So let me take convert double to floating. Say maybe I have F0 to say F4. Now anyone who will tell me how this operation is going to take place? Riya?
मैम इसमें F0 F1 will be a floating pair.
Yes.
Sorry, F
ठीक बोल रहे हो?
and F4 F मतलब F0 जो है वो लोअर रजिस्टर होगा, तो उसके उसके कंटेंट्स F4 में आ जाएंगे.
Very good. So now we have a 64-bit value from Ankit to everyone. It will return to precision value in F4. Okay. Now see, you have a 64-bit value in F0 and F1. So it says convert double to floating. The opcode itself says, you know what it has to do. The opcode says that you have to convert a double precision number to a single precision number. So whatever is in source is by default treated as a register pair, right? And whatever is in destination will be a 32-bit value in one register. This the processor does on its own. We don't have to worry about it. We just should know, you know, how it is doing. So the contents of F0 and F1, I'll just write this for you. So the contents of F0 and F1 are rounded off and stored in F4 as a 32-bit single precision number now. That's it. Okay? Clear? Okay. Now you have to speak something. No, I need an acknowledgement.
Ma'am?
Yes?
But the double is also a 64-bit number. No, double can be a 64-bit also, no?
Yeah, it has to round off. It has to round off. It will ignore some values. Since we are converting from double to four, it will be there. Yes, there can be a data loss also. See, suppose, you know, I have a number right now. I have, say, 15. I can round it off to 20. Are you getting my point? Or maybe I have 115. I can round it off to 120. Or maybe if I have to, you know, lose some data bits, I can say this is somewhere near 100 or maybe somewhere near 200. So accordingly, the processor also does rounding off of the data. Yes, some information might get lost. There are chances. But there are a few operations wherein losing data also does not, you know, matter much. In those cases, we use such operations. Should I move on?
Ma'am, will it not directly ignore F1 and store just F0?
No, it has to round off. It has to round off and then store. Whose doubt was this?
Karan.
Okay, Karan. Which say this has to round off and then store. Otherwise, if it will just ignore the higher order, you know, when we are storing floating point numbers, the numbers are stored, as I was saying earlier also, the numbers are stored as an integer and then 10 raised to the power or e raised to the power something, right? Now, when it is rounding off, it will round off the integer respectively and the floating point value respectively. So your precision value is also stored and the integer value in the data is also stored, but rounded off to the nearest value so that you are able to, you know, you're not able to lose the major information. हो सकता है कुछ data lose हो जाए, but वो near about वाली value आ जाती है. So the processor,
But if the data is 64-bit, so how can it round it to 32-bit?
See, I'll just give you an example. This you would have been taught in your first or second standard, that if we have a number whose ones place is, say, greater than or equal to 5, we round it off to the nearest value, which is 20. If it is less than 5, we round it off to the nearest value, which is 10. So somebody has written in the chat, ma'am, what is the mechanism for rounding off? So this is the mechanism for rounding off. ये first standard में पढ़ाते हैं बच्चे. और अगर 64-bit value होगी तो बच्चे data lose हो जाता है. That's what I'm saying, ना? The data gets lost. This operation itself says that you have to convert from 64-bit to 32-bit. The major information remains the same. जो higher order bits होती है वो same रहती है. Lower order bits का data lose हो सकता है. So I have said this earlier also, that when you are converting from 64 to 32, definitely some lower order bits are going to get lost. But this is an operation which is available as a provision. Don't use it as a coder. It's up to you. Maybe in a floating point operation, you can just move on with losing some data. It's fine. So it actually, coder is the boss. The one who's doing the coding is the boss. It is up to you whether you want to use this instruction or not. I hope everybody's doubts are clear now. Should I move on?
Yes, ma'am.
Yes, ma'am.
The next operation is convert double to integer. इसमें हम प्रिसिशन वाली वैल्यू को पूरा ही निग्लेक्ट कर देते हैं. ये मुझे किसी ने पूछा था कि मैम ऐसा तो नहीं है कि जो डेसिमल पॉइंट वैल्यू है वो निग्लेक्ट होती, नहीं, उसमें नहीं होती, इसमें होती है. सो इफ आई गिव एन इंस्ट्रक्शन ऑफ कन्वर्ट d to I, say from f2 to say R1. Now the precision value, which is the decimal point value, totally gets neglected, and the remaining data is rounded off and stored into R1. So here we are losing on the decimal point value. Convert double to integer. Name itself says what it is doing. एक double precision number तो f2 और f3 में है, f2 और f3 में है, उसको सीधा ही हमने R1 में ट्रांसफर कर दिया राउंड ऑफ करके, और आपका जो प्रिसिशन वैल्यू है वो तो पूरा ही चला जाता है. ठीक है. सो हियर वी आर नेग्लेक्टिंग द डेसिमल पॉइंट वैल्यू एज अ होल. क्लियर?
Yes, ma'am.
Okay, I'll just move on. Yes, there are two more instructions. This is convert integer to floating and convert integer to double. I think you can tell me now. Yes, convert integer to floating. बोलो जी जल्दी से.
F2,
F2 comma R1.
Good. और दूसरा वाला convert integer to double.
R1 F0 comma R1.
Again, the opcodes themselves signify what they are doing. Convert integer to floating will convert the data available in an integer point in a general GPR, general purpose register, to a floating point register by taking the decimal point value as 000, and the integer to double will convert the 32-bit value in any source register to a double precision number by again inserting zeros in the unused places. So the register pair which is taken as destination here is F0 and F1. I repeat, the unused places will be filled with all zeros, but it will be a double precision number while performing any arithmetic operation on the same. Clear?
Yes,
Yes,
ma'am.
ma'am. Ma'am, in F1, there will be all zeros, or in F0?
आप बताओ हायर ऑर्डर रजिस्टर कौन सा है?
Higher order F1.
हाँ, तो उसमें अब आपका डाटा देखो. सी इट्स वेरी सिंपल ऑन अ लेमैन टर्म्स. आपके डेटा का मीनिंग चेंज नहीं होना चाहिए, राइट? If I am placing all zeros in MSBs, means my data does not lose its meaning. While if I am placing zeros in all LSBs, my data loses its meaning. Uska, if I say, for example, I'll just give you in a layman terms. I have a number which is 45. I can represent this number with zeros as 0045, or I can represent this as 4500. Which one is correct?
First one.
0045.
Very good. So accordingly, when the data is getting converted from a single precision to a double precision, in the MSB positions, we put all zeros. So higher order register में हमेशा zeros आएंगे, so that your data does not lose its meaning. It is very simple. You go for any register, any pair, this is the rule that follows. Clear?
Yes, ma'am.
सबको?
Yes, ma'am.
Okay, I'll just move on then. I had to use at Mentimeter also. Everybody, do you have it in your phones?
Yes, ma'am.
Yes, ma'am.
Okay, अब देखते हैं लास्ट में कितना टाइम बचता है. नहीं तो आज इंस्ट्रक्शन सेट कंप्लीट करा के नेक्स्ट टाइम कर लेंगे. Okay. Yes, moving on to the next set of instructions. These are set on comparison. Now see, we had a set on comparison with general purpose register also, like set greater than R1, R2, R3. For GPRs, this set on comparison instructions used to compare the two source registers and set or reset the destination register either to 1 or to 0. If the condition was true, this was set, else it was reset to 0. ठीक है, बहुत फास्ट तो नहीं हो रहा, ठीक है ना?
Yes, ma'am.
Yes, ma'am.
Okay, good. Now, with floating point registers, we again have instructions for set on comparison. Here we have a very, very important register called floating point status register. This is just like your flag register you used to have in other processors. Now, see, this stores the status of comparison of floating point operations. Now, this can hold one value. This can be either a 1 or a 0. Now, when we give the operations like less than floating, less than double, depending upon whatever is the opcode, the source registers are compared. And the destination which has to be set or reset is the floating point status register now. Till here is clear?
Yes, ma'am.
Okay, Sukhmani will tell me now. Just unmute yourself, Sukhmani.
Yes, ma'am.
I give an instruction less than floating. So LTF. So this says less than floating. By default, I am talking about two floating point registers which are 32-bit in length, right? So single position floating point operation. So this says if F0 is less than F2, what should be set or reset?
Floating point register.
Status register. Very good. So this checks the condition which is given in the instruction F0, F2. It compares F0 and F2 arithmetically. If the condition is true, which says, if the first register is less than the second register, the FPSR should be set, else it should be reset. These are normally used when we have to branch using floating point, operations. We are writing a code for floating point numbers, and we have to make a conditional branch. In those cases, we need these instructions. So we'll come to it. I have the examples for you today, but let me just complete with the instructions first. All right. So less than floating. Similarly, we have less than double. अब क्या होगा ये मुझे कौन बताएगा? Just a minute. Harmandeep.
Yes, ma'am.
Now I have written the same instruction with a different opcode. This says less than double F0, F2.
F0 और F1 का डेटा F2 और F3 से कंपेयर करेगा.
Very good. And अगर पहले वाले रजिस्टर पेयर का डेटा दूसरे वाले रजिस्टर पेयर से छोटा होगा तो floating point status
FPSR बन हो जाएगा.
Very good. Next one is greater than floating and then is greater than double. Akash Mishra, unmute yourself. Akash Mishra, I don't have time. बच्चे जल्दी जल्दी करा करो.
Yes, ma'am.
हाँ. Next instruction is greater than floating. F0, F2.
I don't know, ma'am.
So you are lost in some other world. This means सारा तो बता रही हूँ.
Yeah.
See, the instruction says greater than floating. If F0 floating point register contents are greater than F2 floating point register contents, the floating point status register should be set to 1, else it should be reset to 0. Very simple. right? Okay, similarly we have greater than double. Rohan Anand, unmute yourself.
Yes, ma'am.
How will this operate?
If F0 and F1 is greater than F2, F3, then it will set FPSR to 1.
Very good. Next one. Less than equal to floating. Less than equal to floating. Raghav Bansal, unmute yourself.
Ma'am, if F0 is less than equal to F2, then it will set to 1.
Very good. So either less than or equal to. In either of the two cases, FPSR will be set to 1. So they can be equal also. On the one can be less than the other one also. In either of the two cases, कोई एक भी अगर satisfy हो जाता है, तो floating point status register will be set to 1. The next one is less than equal to double. Jashika.
Yes, ma'am.
Pick up.
अगर लेस देन और डबल होगा F1 और F2 तो फ्लोट तो सेट 1 हो जाएगा.
तो इसमें रजिस्टर पेयर कंसिडर हो रहा है, डबल सुफिक्स आ गया साथ में, ठीक है. So
Yes.
the output says less than or equal to. So if F0 F1 contents are either less than F2 F3 or they are equal to F2 F3, in both of the cases floating point status register is set to 1, else it is reset to 0. Okay, greater than equal to floating, GEF, yes. Nehal Arora.
Yes, ma'am. Ma'am, it says that if the contents of F0 are greater than or equal to F2, then it will set the FPSR to 1.
Else it will be reset to 0. Good. So if I take double here, Ankit. Ankit? Are you there, Ankit? Vartika Singh? Vartika, unmute yourself first.
Yes, ma'am.
हाँ जी, बताओ ये क्या करेगा?
मैम अगर F0 F1 का डेटा ग्रेटर देन इक्वल्स टू F2 F3 का डेटा है तो FPSR 1 हो जाएगा.
Very good. So either greater than or equal to. Now comparison is for two register pairs, F0 F1 and F2 F3. Next is equal to floating and then is equal to double. Do I need to explain this? I don't think so. I think I can move ahead now. Equal to floating will definitely compare the two floating point registers. If they are equal in their value, FPSR is set to 1, else it is reset to 0. Equal to double will consider the two registers as pairs now. What if I write equal to double, F0 comma F1. So Abhishek Jain will tell me whether the syntax is correct or incorrect. Abhishek Jain, fast unmute yourself. I'll remove you from my class if you'll not unmute. Okay, this means, I'll presume that you are lost. You just logged in and you have run somewhere else. Okay, thank you, Abhishek. Next is Guneet Pal. Guneet Pal, unmute yourself. Very good. Guneet Pal. Thank you, Guneet. Right. Okay. Mansi.
Yes, ma'am.
How will we? Is the syntax correct? EQD F0 comma F1.
Yes, ma'am. Because इसके अंदर higher order, lower order दोनों एक दूसरे को compare करेगा. Because double है तो 64 bit होना चाहिए. But first 32 bit और last 32 bit को compare करेगा equal है या नहीं.
इसके हिसाब से, according to the instruction, this says F0, F1 are compared with F1, F3. Is the syntax correct? Anyone?
It is wrong.
It is not correct. Very good. You know why? Because I said again and again that whatever register pair convention that the processor is following is fixed. Either it has to be an even pair or it has to be an odd pair. So if it is F0, F1 here, I should have, F4, F5 or maybe any other even pair here. I cannot take an odd pair. This will give me a syntax error. So even pairs have to be compared with even pairs, odd pairs have to be compared with odd pairs. You cannot change, as a programmer also, you cannot change this convention of the pair parity that is considered for the processor. जो एक बारी उसने फिक्स कर दिया उसकी डेटा शीट्स में मेंशन्ड होता है, आप अपनी मर्जी से चेंज नहीं कर सकते. बाय डिफॉल्ट इवन होता है मोस्ट ऑफ द केसेस में. ओके, नेक्स्ट वन इज नॉट इक्वल टू फ्लोटिंग एंड नॉट इक्वल टू डबल. सो I'll just brush up this one and rush through. So not equal to will again compare F0 and F1. If they're not equal, then FPSR is set, else it is reset. Not equal to double will consider the two registers as pair, should be of the same convention. Should I move ahead now?
Yes, ma'am.
All right. Yes, very, very important instructions in terms of coding. Now, whatever we have discussed in the previous lectures, most of the times you're writing codes wherein you have to check whether you have reached the endpoint of the program or not, whether your number is greater than the other number or not. Maybe you're performing a bubble sort, whether it is complete, at what point are you currently working on. So all those things have to be checked using branching instructions. We can have conditional branches as well as unconditional branches for DLX processor. We just have one condition that we check normally, that is compared to 0. So we just check a 0 comparison. For this DLX processor. For example, I'll check, so they have given two instructions, say branch equal to 0 and branch not equal to 0. Some source register and then move to a target. Okay? So say suppose I have given this instructions, branch equal to 0, R1 comma target. This instruction is going to check the contents of register R1. This is just like an if then else statement for a C or C++ code. If true, then branch, else it is the next instruction in the sequence, right? I'll just take an example for you. Yes. Say I have two numbers which are stored at two consecutive locations, and I have to check whether the first number is greater than the next number or not. So what I can do is I can just load the two numbers from two consecutive locations into registers R1 and R2, and then I can compare. If R1 is greater than R2, I will set R4 equal to 1. If R4 is equal to 1, then this means my R1 is already greater than R2. I should store R1 at the location which is specified, else I should store the next number. Obviously, the other number is greater. So what I will do is, I will check the contents of R4 after performing the set greater than instruction. समझ आ रहा है सबको?
Yes, ma'am.
Yes, ma'am.
So I've loaded the two numbers in R1 and R2, and then I have compared. So this says if R1 is greater than R2, R4 is set to 1. If R4 is set to 1, this means it is not 0, right? From the previous instruction, R4 will be set to 1 if R1 is greater than R2. This means it is not 0 right now. If R4 is not 0, I should store the larger number at 24 bracket R3, else I should store the number or the greater number which is in R2 at 24 R3, and then I can jump to halt. So I hope you're getting my point, why we use this instruction. ये clear है सबको?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay, I think we are running out of time also. What is the time?
10:30.
10:30. Chalo, ठीक है, I'll take this up again. We just have to do conditional branches, multiply, and then unconditional branches, and then I guess we are finished with the instruction set. Then we'll do some coding examples, and then we'll start with pipelining and parallelism. यहाँ तक किसी को कोई भी डाउट है तो you can speak up. Any doubts? No. All right. ठीक है बच्चे. Thank you.